concentrations. What's Q?
1.
Q equals 1, E0 equals 0, and E equals 0. So there's no potential across this cell if the concentrations are equal. But when you start to get different concentrations, so if you have 3 molar versus 1 molar, you can easily write the Q for that. It's just one concentration divided by the other, right? And then you can calculate the delta E across that cell. And I'm not going to hold you to the delta E being positive or negative, because that means you need to get ln Q right, but it'll just be the inverse of 1, or the negative of the other. Yes?
What is when Q equals 1, E0 equals 0 again? Is that just because of, is this specific to the concentration cell?
Yes, so E0 equals 0 is, well, it's specific in 2 cases. When does E0 equal 0?
If it's the same metal?
If it's the same concentration on each side of the same metal, but also remember your reference, hydrogen going to H plus 2E minus, E0 is 0 then too. Remember this, so if you look at the concentration cell, we have 2 things going on. We have nickel going to Ni plus 2 E minus, and then you have nickel 2 plus 2 electrons goes to Ni. So we can look up the nickel half cell for this one. Is nickel on here? Doesn't look like it. So I don't know what nickel is. 0.25 volts. This is negative 0.25 volts, right? And so this is E0 cell equals 0 for a concentration cell. And then you just have to figure out this reaction quotient. So the reaction quotient is concentration of nickel 2 plus concentrated over the concentration of nickel 2 plus dilute. So you can figure out the Q from the 2 concentrations, 3 molar over 1 molar, and you can plug it into this formula to get E, your potential difference. Yeah?
0 is always going to be 0 for concentration cells because it's the same substance.
Exactly. Yeah, so E0 is always 0 for a concentration cell because it's the same half reaction, just going in different directions.
And it's only driven by difference in concentration.
Exactly. So we can use this Nernst equation works for anything, right? So if you have nickel and cobalt, you can still use the Nernst equation, just E0 won't be 0. So we can figure out E cell for this one. E0 cell. And we can use Nernst equation and we can plug in, figure out the reaction quotient and plug it in here to get the real value. So you had that problem right on your homework, so you should know how to do that. Other questions? I don't see any hands going up. So, yeah.
After this exam, what else is contributed to our grades?
That's it?
That's it. So, will we get to decide whether we should take a final? Like, we have enough data to judge?
Yeah, you can just show up for the final if you want. Now, I'd like to know if you're going to show up or not, because that will determine how many copies I print. But I'll make sure, so if you get paranoid that morning and want to show up for the final, you're happy to show up. And I will decide for you what's your lowest grade, and I will drop that one. So I won't, make you count a grade that you don't want. So, and you can ask me on the after you take your exam on Tuesday, I'll have all your homeworks, I'll have all your test scores, I'll figure out your final grade on Thursday. And so if you don't know what your grade is, feel free to email me on Thursday. And I'd be happy to tell you what it is, and then you can decide if you want to take the final or not. But the final will not hurt you, so it's okay to take the final, to try and beat your lowest test grade. And then, I'll just drop the low one, right? If the low one's the final, I'll drop that. If the low one's exam number 1, I'll drop that. So, taking the final will not hurt you. It can only help you. But if you've got a 98% in the class, there's probably no reason to take the final. But if you've got like a 92 and you want to try and get an A, it might be worth it to take the final. Or if you've got a B, you say, well, I'm good with the B. But you could probably do better. So if you take the final, you might be able to raise that up a little bit. So I promise that taking the final will be helpful. And the final will not meant to be the lowest grade. The final will be meant to recap the whole course. It's not going to be killer final. Yes?
You have down here phase stability diagrams.
Oh, yeah.
What are those referring to?
Yeah, so what I wanted to make the connection on is that a Porbet diagram is a phase stability diagram, right? It tells you what phase occurs under what conditions. And so I just wanted to make sure that you knew what general class of diagrams a Porbet diagram belonged to. Yeah?
Did you drop our 2 lowest homeworks or just 1?
2 lowest homeworks will be dropped, yeah. Yes?
And then passivation coding, are you just going to ask like this one, water can get in easier than this one, so the second one will be the better one?
Exactly right, yeah. Which one lets in water and oxygen? Which one excludes water and oxygen? Which one is, tough ductile material? Which one is crumbly and porous? You decide which one's the better passivation coding.
So you'll get some characteristics.
Yeah.
Wait, so how do we know that again? Like which one is porous and which one's not?
I'll tell you which one is porous and which one is not. You need to tell me which one's the better coating. Yeah. So right, if you have a porous coating or if you have a coating that's non-porous, which one is the better passivation layer? The non-porous one, right? Doesn't let any stuff through it. And I will tell you which coating is which, and you have to decide. I might tell you that I have a paint that doesn't stick very well to the surface and it flakes off a little bit versus a paint that really sticks well and excludes oxygen and water. Which one's the better passivation coating? Second one. Yeah. So it'll be that easy. But you'd be surprised. Yeah.
Is the cutoff for an A in this class a 94?
Yeah, whatever it says on the syllabus. So, and that includes, so officially the university says that it has to be a 94 point something to get an A. But if you have a 93.5, you usually round that to a 94. And if you've answered a bonus or 2, that'll put you over the top. So the bonuses will be worth half point, 1 point. They won't be worth a letter grade. They won't be even worth half a letter grade in some instances. So it won't take you from a 91 to a 94. That's not what the bonuses are meant to do. There's too many people. And so I'm not going to give anyone 2 or 3 percentage point bumps. But it'll be, if you're borderline, you'll make it over the hump.
Will you include that when you send out the grids on Thursday? Like what would be?
Sure, yeah, I think I can make that call.
All right,
Yeah.
thank you.
Or I might tell you, you have a 93.5 and you've answered 2 bonuses, so you're probably okay. Yeah. Well, and if you're not okay at the end of the semester, I'm here all finals week. Just come on in, we'll talk about it. But I don't want to see any of you guys in August asking me about your grades. So we'll sort it out during finals week. Yes?
You put up the 2 equations for the first and second rate law, the 0th order.
Yeah.
Is that just rate equals initial rate?
Rate.
Or that's K?
Rate is K, right? And so what does the concentration of A look like as a function of time? Straight line, right? Doesn't depend. So the concentration of A as a function of time, it actually goes down, right? You're using A. A plus B goes to C. You're using A, and the slope is just a rate constant. Yeah. So the concentration of A goes down, right?
Wait, so should it be KT instead of K? If it's dependent on
Yeah, you're right. You're right.
Isn't it just a horizontal line?
Yeah, for 0th order. You just don't have linearized.
Is 0 order?
It's constant.
It's a linear.
What's that?
It's already linear.
It's already linearized. Hold on. Let's see what we have for. I want to give you the official story here. Yeah. So, it's already linearized. So, in this one, right, when we have a second order or a third order, rate equals k times, there's no time. There's no time in this expression either, right? So, we know that we're going to use up a as a function of time. So a goes down as a function of time. What's this point right here? A0, right? We use up a as a function of time, and the slope is the rate constant.
So when is it a horizontal line?
When is it a horizontal line? Oh, it's a horizontal line when you have rate as a function of A0. Rate does not depend on the concentration of A, so the rate is the same. That's when it's a horizontal line. It's not a horizontal line as a function of time. What if you have this? What does this mean? What does that mean?
Zero.
No.
Nothing happens.
A is not reacting, right?
Equilibrium.
Ooh, that's a good one. You're at equilibrium, right? A is not changing as a function of time. Nothing's happening. Yeah, so I think when we drew a horizontal line, the rate wasn't changing as a function of our initial concentration. That's the definition of a first order. Yeah?
The graph where you have the concentration, that's not the graph of the rate, right? That's the graph of the concentration.
This is a graph of the concentration.
So it's like differential.
This is a graph of the rate. Yeah. So this is AT, right? The differential, the concentration as a function of time. Yeah.
So all n